Hello and welcome to my 9th video. This video is about sealed secrets. It's a DevOps tool made for GitOps. I hope you are coming with your coffee mug ready and ready to join the session. Storing passwords in Git repositories is a big security hazard. Basically you're exposing your system's configuration and secrets to the world if there is a breach happening. And GitOps practice, which is one of the latest practices in DevOps, with infrastructure as code, suggests you store everything to build up your infrastructure in a Git repo. But that's exactly what we talk about. There is a security breach potential in there. Why is that? Maybe your Git repo is public, the thing that we are going to explore today in our architecture. Sometimes the Git repo is private, but there is probably a potential of the breach of that Git repo. So probably somebody steals the laptop of company and they just gain access to the system, or sometimes they hack it into the systems of the company. Or sometimes we just see that the laptop is just open and the person that is working with it, he doesn't know that specific secret. It goes to the production and uses it to push some images, and all of a sudden you see the production is going down. All of these ones, they may be a security breach. Sealing secrets with Bitnami sealed secrets is going to solve the problem. How it's going to work is like this. So we have a secret, we have a password, we can use the kubeseal command that encrypts the secret into sealed secret. Then we can use this sealed secret and put it everywhere that we would like it to be, like Git repo or anything like that, like any code repo or config repo. It doesn't mean it can be even open, like open to the public. It doesn't matter because we have completely sealed the secret. And then when the application is going to merge inside the system, inside the Kubernetes cluster, there is a component of sealed secret inside there that's going to decrypt it and make it usable for every application inside the system. The sealed secrets is using asymmetric cryptography. So that's a fancy name for public-private key cryptography that you see everywhere on the internet. So if you're using HTTPS to access your bank account's URL, you're using the same approach to sealing the secrets or securing your connections. So how it works really is like this. Each of the players in the network, they have a public key and private key. So Alice, you have a public key and private key, and Bob also has a public key and private key. We are going to store the private key very secure in our system. And we are going to have a public key also. The public key is a key that we are going to pass it to the other party. It's completely safe to even pass it over the internet, because if somebody gains access to it, they cannot decrypt the message. You are Alice, you have a plain text, probably a message, and you want to send it to Bob. You use Bob's public key to encrypt the message, as you can see in here, and gain a ciphertext. And then you're going to send the ciphertext over the internet. So if there's somebody here gaining access to your network, they cannot find out about what is inside this ciphertext. Then we are going to use the private key of Bob to decrypt the message and gain access to the plain secret. In a nutshell, you should keep your private keys very secure, and you can just give away your public key. That's the same approach that's happening with the sealed secrets. You're having a private key, you're storing it completely secure in the Kubernetes cluster, and you're giving out the public key of the sealed secret so that every kubeseal application can use that one to seal the secrets. Sealed secrets also has additional perks in there for us. One of them is that you don't have any maintenance overheads. We are going to install it and forgetting about it. You don't need to attend to it. The next one is that installation is very easy with GitOps practice. We are going to try it today. And also it's production safe. Every 30 days, it's renewing the public and private key. So public and private key by themselves, they are very secure. Imagine rotating them every 30 days. That's like a very high standard in the industry. This is the architecture that we are going to implement today. Pretty big, huh? So we are going to have a Kubernetes cluster. We are going to create a new repo on the GitHub, and we are going to configure that repo inside ArgoCD. So ArgoCD can read from the repo and install Bitnami sealed secret firstly, and then we are going to install a sample application using some secrets. We are going to install the whole architecture today. Bring your computer ready and follow up. Okay, I have the YouTube materials in here. We have ArgoCD sample. That's an application. We are going to put the sealed secret in here. And we have Bitnami SS. We are going to use this one to install our Bitnami sealed secrets inside the cluster. And we have the cluster here, just provisioned it. Now let's go and connect to it. Okay. We are in JKE. Let's go and install the ArgoCD. It's as simple as this one. We just copy and paste it. It's completely okay if you wanna go in and like copy and paste from the website. Even in front of the others or inside the interview, nobody expects you to really know these things. Specifically these days, they are becoming more complex on a daily basis. The thing is that you should know the concepts whenever they are asking you. So we are having here the ArgoCD being installed. Just we are going to check if it's okay in here. kget-ns means getting the namespaces. We have ArgoCD in there. Let's go see if the pods are running. -n ArgoCD. I highly suggest enabling the autocomplete in your kubectl commands. We are having here the ArgoCD Redis is running. We are waiting for the server to be created and other ones. I've noticed that it's pretty slow in here compared to our systems on IBM. Although I don't like IBM Cloud, but I see it's much more slower in here. Like literally I'm like waiting about how much, like 40 seconds, 45 seconds. If you see crash loop back off in here, it's completely okay. Yes, it's going to being fixed after some time. So now we have everything being running in here. Get svc -n ArgoCD. So we have many ways of connecting to our ArgoCD's main server, meaning this one. We can create one ingress. We can make this one of a type of cluster IP of a type of load balancer instead of cluster IP. So we can have an external IP in here, or even we can create some kind of like cloud URL pointing to this one. Currently what we are going to do is the simplest way of doing it, and there's also another way. You can do the port forward and then use that port to connect to ArgoCD server. Here it is, the command that makes that of a type of load balancer. Running that command, getting the service again. You can see here the public IP is pending. Depending on your cloud provider, sometimes you need to provision the public IP or get the public IP from the cloud provider beforehand. That's a thing that happens with IBM. In Google, usually it takes a bit of time, but they're going to allocate it to you. Going to review our architecture. So this is the Kubernetes cluster. It's in place. We have the ArgoCD. It's in place. The next one is to configure the repo and add the Bitnami sealed secret there. Okay, let's see again if it's yes. So the public IP is allocated to us. One thing that I really suggest in here is go in and change the password. The password is the pod name of the ArgoCD. So this is the pod name. So ArgoCD login and use this. It's completely normal to get this one because it's hosting the ArgoCD from inside with the certificate that is created inside ArgoCD. The username is admin. The password is this one. So we have successfully logged in. ArgoCD account update password, I imagine. Yes. The current password, we are going to copy it again from here. It's all updated. Let's go and see our ArgoCD. It's completely okay again to see this one because Mozilla is telling you that this is like self-signed. when you're having HTTPS, but the HTTPS, the public key is not signed, it's going to give you this one. Here you can get in with the same password. Let's go in and create a new app that is Bitnami Sealed Secret application, Bitnami SS. I can say sync policy should be automatic, prune it, self-heal, and auto create the namespace. Here we are having the repository URL. Let's just fetch it from here. We have the Git repo. Yes. It's going to show you the path. You can see here, Bitnami SS is already in the path. Cluster URL, it's inside the cluster. We are going to name the namespace. And that's it. To install this one, I'm going to click on create. Let's go and review the installation files. We have Bitnami SS. This is the controller that you get from the Bitnami. Let's go inside the website. Bitnami Sealed Secrets. Made a mistake, we should go to the releases. So in the releases, you can see it's version 0.15. Bitnami has a Helm chart. Helm chart version usually starts with the same version number, just here it is 1.15, and the controller itself is 0.15. Different people are maintaining Helm chart and the controller. My suggestion is to go with the just plain controller. Here it is. How you can do it. Here we have the controller by itself. Just there is a catch to it. You can install controller, but it's going to install in the kube systems namespace. For some companies, it's not preferred. We want to have it in different namespace. You cannot use kube apply -f and -n to specify the namespace. What you should do is having a customization in here. So Customize is an application for Kubernetes that helps you being more declarative regarding how to set up the system. Let's review here. The name should be customization.yaml. The name, you are going to specify the namespace and you are going to say which resources it should work on. And here we say that controller.yaml. Here we say that everything that is inside controller.yaml, the namespace should be bitnami-ss. That's the same name that we have chosen here. Bitnami-ss, this is the path, this is the namespace. Here you can see it's completely healthy, it's synced, it's okay. Let's go in and check it. -h. It's pretty handy. Please use -h whenever you have some questions. Here we want to specify the namespace's controller's namespace. So kubeseal. Namespace is bitnami-ss. Basically, if this one doesn't crash, it means that everything is in good order. We have the Kubernetes cluster. We installed ArgoCD in there, and then we configured ArgoCD to use config repo to install Bitnami Sealed Secret. Next thing that we are going to do is to install the sample nginx with the repo that is in here to here. So this is Argo sample, the nginx deployment and service one. Progressing to create the nginx deployment. Let's go to the Bitnami Sealed Secret and use their own material. Here it is. We are going to create a secret in here. Vim my secret. You can see this is a secret in here. And the data is foo ymfy, just something dummy. In the kubeseal command, when we want to specify a different namespace than default, we should really talk about it. Here it is. So -n should be there. Here you can see the namespace has changed to sample nginx, deleting the main my secret one from our folder, and then adding. Okay, it's done. Just reviewing it in here. Here it is the namespace. Here we can just sync it. Here it is the my secret one. That's it. We have installed it, configured it, and enjoyed its benefit. Thank you. Try it yourself at home and have a great one.